Hi there and Happy New Year. Welcome to a new edition of Space Nuts. My name is Andrew Dunkley, your host. Great to have your company. Hope you had a great Christmas and New Year and looking forward to getting your brain crammed full of stuff from astronomy and space science over the next 12 months or so. Coming up in this episode, some really interesting stories, a proposal to develop an expandable space station. This is one that you launch and then you put it out into space and then it just sort of blows up. Not catastrophically, but it expands and it'll be bigger than the International Space Station, apparently. Strange new caves on Mars. We'll cast an eye on that. Oh, yeah, think about it. That's a good joke. And observations of a rogue planet. We'll talk about all of that on this New Year's edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And he's back for more in 2026. His name is Professor Fred Watson, astronomer at large. Hello, Fred.
Happy New Year, Andrew.
Happy New Year to you too. And Marnie?
Yep, Marnie's out at the moment, but I shall pass on your greetings. I can't believe that we're now more than a quarter of the way through the century.
I know.
Where did it go?
It's just flown. And I can't keep up.
Well, you're obviously managing because you're still here.
I'm still here, yes.
And I must be too, because I'm still here as well.
Yes, we are. And onward and upward. Did you have a nice Christmas, New Year, all that? Get any nice prezzies?
It was great, yes. It was a quiet festive season because, as you know, we've been everywhere the 2 months before.
Yeah.
And so we finally found our feet again and sort of more or less settled back into home life. I might mention the Prezi that I've been really enjoying, and that is it's almost like a dongle that plugs into my old iPod. How old is it? It's 18 years old now, my iPod. Still in perfect working order. This is a good advert for Apple. But of course, it doesn't have Bluetooth, and all it has is a little audio socket.
Yeah.
But the dongle, you plug in this small box into the audio socket, switch it on, and it's live on Bluetooth.
Wow.
And the sound quality is unbelievable compared with a straightforward wire to your headphones.
Yeah. Isn't that good? It's
Yeah.
good that they can come up with technology to make
sort of
old technology on iPod work in the modern era.
It's really meant for people getting on aeroplanes.
Yeah.
So you can plug it into the audio socket in your seat back and listen on your Bluetooth headphones. But for me, it's just a joy because the old iPod has got far more music on it than any other device that I've got.
Yeah. I put all my music on my phone.
Yeah, except it falls off your phone. Mine certainly does. So we could talk about that later.
I haven't had that problem, but yes, we might look into that. Yeah, interesting.
It falls off.
It's hard to know what my favourite gift is, but I think it's it might be my rock box. You know how I steal rocks from different parts of the world?
Yes, you do. Often illegally.
Judy's got a display case for me.
Oh,
and
fabulous.
So, and she bought me a labeler so I could put all the names down. So it's sitting just over there.
Next time
I'll get it out and show it. Yeah.
I'll have a look.
Some good gear in there.
Yeah.
Everything from a rock from Mount Etna to shrapnel from the Western Front.
Yeah.
Yes,
yeah.
I'll pick up anything.
Yeah, I think you've got the odd meteorite in there as well.
I might have,
Yes.
It's very possible.
From, and Etna, Vesuvius.
Etna, there's a few. Yeah, I can't remember them all now. Teide, Mount Teide.
Oh, yeah, in Tenerife.
Tenerife, yeah.
Yep.
Shall we get stuck into business? Because, we could talk about our Christmas presents all day.
God, aren't we pathetic? I do apologise to the audience. This is what comes of being just adequate, really, isn't it?
We're just being old and dodgy, that's what. That's what it is. Let's talk about this proposal to develop an expandable space station. This looks like something out of a science fiction movie when you look at the images. Obviously, they're artistic impressions because they haven't actually launched this thing yet. But the idea behind it, and they're talking about putting it up sometime next year as a test case. But you take it on a rocket, let it out, and then it just expands out into the space you want. You can do whatever you like with it.
It's I think, we're seeing the future here, Andrew. And at the same time, we're looking into the past, because in the early 2000s, a company called Bigelow Aerospace, thank you for reminding me of that name 10 minutes ago, because I couldn't remember it. Bigelow Aerospace, which actually is the same company that owned a chain of hotels and motels, I think, in the USA. But they pioneered the idea of inflatable spacecraft. And I've forgotten what the name of the spacecraft were. They had two, which were both launched. And one of them it was full of photographs of people who'd sent their photographs to be put inside this inflatable module. And so they were floating around in weightlessness. They had a camera looking at everybody's picture going past. Yours might have been one of them, actually.
I can't remember if it was that one or something else.
It was something like Merlin or Hermes or something like, I can't remember what it was.
Right.
Anyway, but there were two of them, and they demonstrated pretty successfully that an inflatable spacecraft is a viable proposition. And, you might think, oh my God, what happens when you get a micrometeorite? But it turns out that you can put, various fabrics, the sort of stuff that you put in bulletproof vests. You can actually layer the fabrics that you use in the inflatable module so that it will be moderately resistant to micrometeorites. And that, I think, might have been what sparked this new idea. I'm not sure whether the new proposal owes anything to Bigelow Aerospace. It might be the same company with a different name. It's a company. Sorry, go ahead.
No, it could be. I was just You never
it's
know.
A company called Max Space, and basically they've unveiled something, a proposal, which is called the Thunderbird Station. Love the name, which has been announced within the last week or so, and it's a large inflatable habitat that's got much more internal volume than your typical thing that you launch that is rigid. In fact, I think it's I can't remember the exact dimensions, but it's something like 3 times the volume of a standard ISS module, one of the modules that goes to build up the International Space Station. So the main factor is it's launched in a compact form, but it expands to 20 times its launch volume once it's in orbit. And you don't need to assemble it. You press a button and there's a hiss, I guess, and there it goes. You've got your inflatable module. And so there is a flight being planned on a SpaceX rideshare mission, as you said, next year, in which we might see a test version of one of these, their so-called mission evolution flight, to validate the on-orbit deployment of the module and actually test its, how resilient it is to micrometeoroid impact. So interesting stuff.
Yeah, it is. And this is probably just the beginning of a potential new way of dealing with space tourism, because at the moment you can go up and do a little bit of floating around and then come back down again. You don't get a heck of a long time up there, and it costs you a fortune.
3 minutes.
Yeah. But this could take it to a whole new level.
And I think that was the motivation behind Bigelow's ventures earlier in the century. So but it clearly has merit. If you can make it with the right degree of protection, you are finding a cheap way of getting large volumes into space. Of course, the downside of that for astronomers is that these things, being big, are going to be much more reflective than your average spacecraft.
Yeah. I've got a scenario in my head. Oh, look, I think I found planet. What's that? No,
it's Thunderbird.
Got in the way.
Yeah, that's exactly it. That you've got you've got satellite trails basically interrupting your observations.
Yeah.
We're already seeing it with Starlink in a big way, with something like, I think it's 8,000 now that are operational, and that's going to go up to 12,000 probably by the end of the decade, and maybe more in the next decade. What I guess the MaxSpace project has in its favour is that these won't be launched 20 at a time like the Starlink satellites are, because you won't need that many of them. So they'll be probably more like, in terms of space rarity, more akin to the International Space Station, although I'm sure the plan is to have many of them, but perhaps not hundreds or thousands, enough to satisfy the needs of people wanting to put experiments into microgravity.
Yeah. And as I understand it, that original idea from Bigelow Aerospace was looking at commercial space stations and smaller stations for other purposes. And I think I found some of the names. They had one named Nautilus.
Okay.
There was Space Complex Alpha,
Right.
Space Complex Bravo, and another one called Skywalker, apparently.
None of which ring any bells. But...
No, right. Didn't remind me of anything either. But
yeah,
this is probably a step towards better ways of putting hardware into space. But I don't doubt that the day will come, Fred, where you'll be able to launch a purpose-built space station which will rotate and give you gravity, and you'll be able to spend a couple of weeks up there just, giving the rest of the planet the bird, or whatever it is you do when you go up. I don't know what you do when you get out there. You float. And
I'm sure you do, yes, at the moment. So I think I've seen so many headlines over the holiday break, but I think I saw one. Was it a Chinese or maybe a Russian mission being planned, which would have an artificial gravity system? So something that will rotate about an axis to give you artificial gravity, which we know will work. And as I've mentioned before, Tom Spilker, who is married to Linda Spilker, the great Cassini mission scientist and Saturn scientist. I think she's still working on some of the missions designed to go and look at Titan or Enceladus, those moons of Saturn. Her husband is somebody who specialises in designing artificial gravity systems for orbit, and I think he's worked with NASA, and so we might see something popping up out of their media pages sometime down the track as well.
That would be interesting, yeah. It's only a matter of time before we get there. And yeah, this sounds amazing. And it reminds me of those pop-up caravans, they were invented a long time ago, but you go and park your caravan, push a button and the whole thing opens up, and there you are. You suddenly got more space. And that's more or less what this is about. And you can configure it to whatever needs arise. So it doesn't. It's a one size fits all. But what you do on the inside's up to you, by the sound of it.
Yeah, that's right. Yes, so you and that's kind of what you want. It's just like an office block where you rent out the space and your clients take whatever they need to do their work. It's laboratories or engineering centres or offices, whatever.
Yeah, so we will look forward to that test flight in early 2027 from MaxSpace. If you want to read all about it, you can do so on spaceconnectonline.com.au. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Let's take a break from the show to tell you about our sponsor, Anti-Gravity A1. Have you ever wished you could actually feel what it's like to fly? Not just control a drone from the ground, but truly experience the air around you. Well, that future has just arrived. Introducing the Anti-Gravity A1, the world's first all-in-one 8K 360 drone. And it's officially available now. This isn't just another drone. It's an entirely new category. It's the most intuitive flight system ever created, easy for beginners, but still offering full FPV controls for seasoned pilots. And the whole drone weighs in at just 249 grams. That means travel ready, regulation friendly, and it fits in the palm of your hand. Plus, Anti-Gravity A1 is packed with smart tools. SkyPath, which lets you design and automate flight routes. Sky Genie, which performs complex flight moves with one tap. And Deep Track, which locks onto subjects with amazing precision. And even Virtual Cockpit, where you can fly maybe alongside a dragon, if you like. Yep. It's repairable, thoughtfully designed and built for creators, and it's already won major awards from Red Dot, Time, Good Design and CES. The Anti-Gravity A1 is now available in 3 bundles at the Anti-Gravity Store, Best Buy and authorised retailers worldwide. So if you ever wanted to rethink what a drone can be or what flight can feel like, check out the Anti-Gravity A1. Just tap on the link in the show notes.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, Fred, more and more news keeps coming out of Mars, and this is quite an incredible discovery. They have found caves unlike any found on the planet before, and we've got the same kinds of caves on Earth.
That's correct. I thought you'd like this story because you're a Mars aficionado. A Mars tragic. So the scientific paper, which is published this week, I think, in the Astrophysical Journal Letters, which is one of the major astronomy journals and space science journals in the world, and the paper, which is by, I think, entirely Chinese authors. I'm not sure. Maybe there are other nationalities in there, but principally Chinese authors. It's called Water-Driven Accessible Potential Karstic Caves in Hebrus Valles, Mars. And the subtitle is Implications for Subsurface Habitability. In other words, could living organisms be found in these caves, or evidence of there having been living organisms? So what these scientists have done is, and this again is a beautiful illustration of the fact that we've got so much archival data now, not just on the universe at large, but on the planets as well. What they've done is they've basically surveyed space-borne photographs of Mars by using data from various spacecraft. I'm sure they've used, the HiRISE camera on one of the Mars orbiters. Mars Global Surveyor is an older orbiter that they used data from. So these spacecraft have got a huge wealth of information about the planet's surface, which has not all been trawled through. Yeah, we're still seeing images that have probably not really been examined before. And what they've done with these data is looked at a region called Hebrus Valles, Hebrus Valley, I guess you'd translate it as, which is in Mars's northwest. So it's very much in the region of Mars that is less mountainous. The southern hemisphere of Mars, as we've talked about many times before, is mountainous. It's covered in craters. The northern hemisphere is much flatter, many fewer craters, and at a lower level. I think it's about 3 kilometers on average lower than the southern hemisphere. That's something called a Martian dichotomy, by the way. So what they've done is they've looked at what look like pits in the landscape, and that's not that unusual to find things like that, because we know of many features that sort of speak of as being, they don't speak, but they, what you see tells you that they are probably lava tubes. They're probably, places which we have here on Earth as well. I think you and I have both walked through lava tubes in Hawaii, which are like long caves where the lava was flowing and gradually dried out, and you're left with a long cave. So these are quite different. The newly discovered ones they're what are called skylights. So that tells you that they are openings in the roof of caverns, but the structure of them and the sort of features around them and the landscape that they're in suggests that these are not lava tubes because that's sedimentary rock that they're in. It's not volcanic rock. So there's some of the data that they've looked at shows in the surrounding rock around these caves, carbonates and sulfates. And so that's basically a water, a water-driven rock or a water-formed rock. And they're suggesting that what you're seeing is caves that are formed by water underneath the surface flowing and dissolving the bedrock. And that's what we on Earth call karst topography, hence casting your mind forward or backwards, or whatever you said at the beginning, Andrew. So it's that gives you a landscape that's punctuated often by giant sinkholes, which is a bit topical at the moment because they've just got one in Melbourne that's probably to do with tunnels being dug. It's a big sinkhole in a sports oval that has not become popular. It's 8 meters across. I don't think that's anything to do with water-soluble rock, but probably more like might be tunneling. Don't know. Anyway, karst scenery generally on Earth is this within limestone regions, and there are places like that in the United Kingdom, not very far from where I grew up,
and Mexico. They have
Mexico, indeed. Slovenia has the most wonderful system of karst caves, which I had the pleasure to go and explore with a colleague from University of Ljubljana a few years ago. Sensational stuff. If we find the same thing on Mars, that is going to be remarkable. But the point that the authors of this paper are making is that that might provide a suitable habitat, suitable environment for microorganisms because you're protected from the radiation of the from the sun, the particle and ultraviolet radiation. And it could be that living organisms have found there a place where they could evolve and develop. So there might be evidence of microbial life there, which suggests that this part of Mars's surface might be a good place to send a rover. And I think that's the bottom line of their article.
Yeah, I've thought of a name for it. If they want to send a rover down, they could call it Spelunker.
Call it what?
Spelunker. Isn't it called spelunking when you go down caves? And
because of speleology.
Yeah.
Yeah.
It's spelunking. They could call it spelunker.
I like that. Yes. Yes. Sorry, that went over my head briefly.
Oh, that's okay. Yeah. Actually, I learnt that word when we visited Hawaii, and they told us how people, go traveling down lava tubes, not the tourist ones with the electric lights in them, but actual, uncharted ones or ones that they know about and they're just it's like mountain climbing, but the opposite.
Yes. Yeah. You can get into all kinds of trouble.
Oh, yes, you can.
Especially with underground river systems and things of that sort.
Yeah.
It doesn't float my boat, I have to say. The idea of climbing into a cave with a not a snorkel, but a basically breathing apparatus.
No, there's been a couple of famous cases over the years of people who didn't come back because they got themselves into difficult situations, and it is a really dangerous thing to do. But what's another interesting thing about these caves is they're enormous.
Yes, that's right. They're not small. They're it's I guess again to use a metaphor, it speaks loudly of the volumes of water that must have basically flowed down them in the millennia ago when they were being formed, because I guess we're seeing evidence of water-driven erosion, and we know that perhaps 3.5 to 4 billion years ago, Mars was wet, but isn't now. So we're looking at very ancient water flows. But yes, it says that there must have been a lot of water there. It's a remarkable piece of work. I haven't looked at the original paper in great detail, but will do because it's such an interesting topic, and they've done a lot of very careful work on this.
Yeah. Some of these cave openings are over 700 meters wide.
Yeah.
Which is extraordinary. 350 metres seems to be a common number, but some of them are almost double that or over double that.
So it's sort of makes you wonder why we haven't really seen these things before.
Yeah.
I suspect what has allowed these authors to make the deductions that they have is because they've used many spacecraft, HiRISE, as I mentioned, the high-resolution camera on Mars Reconnaissance Orbiter, and the Mars Global Surveyor. These spacecraft have basically given you different angles on the same features on the surface, and seeing the surface under different lighting conditions. So when you take all that information together, that's when you can start looking effectively at three-dimensional views of what these dark splodges on the surface mean. They're dark because you're looking down into a cave. And yes, you're absolutely right with things that are, hundreds of meters across. They're not small.
Here's a question. How would they go as potential future human habitat?
I think that would be very much on the agenda too. Just because you really want to find, if you can, a region of Mars's surface that protects you from the environment, which is very, very inhospitable, not just because the atmosphere is only 0.6% of the Earth's atmospheric pressure, but simply because of the radiation, the fact that there's no magnetic field on Mars to protect you from that, and that sort of thing, the UV radiation from the sun. So people have certainly suggested the lava tubes as future human habitats, but these might be even more appropriate, being, as we say, they're very large and probably environments that would lend themselves to perhaps building a structure inside that would allow you to work in normal atmospheric pressure.
I suppose the question becomes one of whether or not that's a part of Mars where there's an advantage being there. I mean, it might be a great cave to put a dwelling in, but if it's nowhere near anywhere you need to be.
But if it's also a place where there may have been microbial life there, it is going to be a place of interest. And of course, you'd want to make sure that you're not building your underground dwelling on some poor animal's habitat, even if the animal itself is long gone. And again, that comes back to some of the ethical considerations in regard to the exploration of Mars.
Yes. Well, maybe we should talk to Elon Musk about habitats on Mars and human ethics.
I'm not going to buy into that one.
I'm going to get you one day.
Yeah.
Yes. It's a great story. If you want to read about it, you can do that at the dailygalaxy.com website, or you can read the paper in the Astrophysical Journal Letters. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson. Let's take a break from the show to tell you about our sponsor, NordVPN. And we're very proud to have partnered with NordVPN so that we can get you more secure online, no matter what you do, where you are, or how you do it. Now, if you sign up using the code word SpaceNuts, you'll receive 4 extra months absolutely free. Top-tier VPN protection at a fraction of the cost. With NordVPN, what you get is access to over 7,700 servers worldwide, ultra-fast connections, advanced features like Threat Protection Pro and MeshNet, and secure usage for up to 10 devices simultaneously. So you're pretty well covered, you have to admit. Now, this is a great opportunity, and if you'd like to take advantage of it, visit nordvpn.com/spacenuts to claim your exclusive offer today. And remember, with NordVPN's 30-day money-back guarantee, it's risk-free. It's a great investment, a small price to pay for your online security and privacy. Stay secure, stay connected, and keep exploring the cosmos with confidence. nordvpn.com/spacenuts, nordvpn.com/spacenuts, and don't forget the code word SpaceNuts at the checkout.
0G, and I feel fine.
Space Nuts.
Our final story, Fred, takes us to another planet, which is a little unusual. We've spoken about rogue planets before, But now we've got, I believe, observations of a rogue planet. Now, these things are hard to spot because they don't orbit a star. They're just floating out there like a space station and turning up who knows where. But apparently they've observed one.
Yes, in a new way.
Yeah.
And that's because I think that these things are relatively commonplace in terms of being found, particularly on surveys looking at what's called gravitational microlensing, because that's really the only way to find them, because exactly as you've said, they are not illuminated by a parent star. I always think rogue planet is a slightly it's an uncomplimentary name. I think orphan planet's a nicer one, because we think some of these are orphans in the sense that they've been booted out of their parent solar system by gravitational interactions. But as you say, they are dark. They're not illuminated by their parent star. They do have very low levels of infrared radiation, because there are, as with the Earth and the planets of the solar system, there are sort of low-level nuclear processes going on inside. That means the planet is radiating its own heat to some extent. I think, if I remember rightly, Jupiter radiates 1.8 times as much energy as it receives from the sun. I think that's the figure, because of the nuclear processes in its interior. So that would be true of a rogue planet as well. So if you've got really sensitive infrared equipment, in fact, things like the James Webb Space Telescope would do the trick, then you can find it. But the sort of standard method of finding these things is by, as I said, gravitational microlensing. What does that mean? It means that you take repeated images of a patch of sky that has stars in it, and most of the sky has stars in it when you look through big telescopes. So you take repeated images of the same patch of sky and look for changes in the brightness of the stars. Now, sometimes those changes are because the stars themselves are variable. They vary in their light output. Sometimes there are changes because it's not a star, it's actually an asteroid, so it means it's moving in your field of view. But one of the potential changes, and you can spot it because what we call the light curve, the way the light behaves with time, has a very characteristic shape. That is when you get something dark, or less bright than the star behind it. It passes in front of a star, and because of Einstein's general theory of relativity, we know the gravity of that dark object will warp the space around it and behave like a lens. And the effect of this lens passing in front of the star is to give you this light curve, which has got a really strong peak and side lobes. The shape is very characteristic. So various planetary systems have been discovered that way. You see a star going past and that has a different shape, and then a planet goes past and that's got this little pointy light curve shape, and you know you've found a planet around a star. But if you just get the pointy light curve, the small one, then that's a planet on its own, basically, which is when we call it a rogue planet. So this observation is of a rogue planet, and it's been made in exactly that way by gravitational microlensing, but it's been observed from both Earth and space. That's the thing. These are simultaneous Earth and space measurements, and that allows you to check the timing very accurately of the gravitational microlensing. The Space Telescope was the Gaia Space Telescope, which has been surveying stars for the last 15 years or so, I think. And because you've got two observations from places that are separated in space, that allows you to say a little bit more about the object, because the trick with these things is you only see this thing once. You see a gravitational microlensing peak and then it's gone. And all your information is in the shape of that light curve. But if you've got two light curves from two different vantage points, you can get a little bit more. And so what the scientists who did this work have said is that enabled them for the first time to work out the mass of the microlensing planet, which is about 22 times the mass of Jupiter, and to say where it is. And it's something like 10,000 light years from the centre of our galaxy.
Oh, I calculated 9,780, but no, that's okay. Just round it up.
10,000, yeah, it's near enough. 9,780, well done.
Yes, well,
You multiplied-
3,000 parsecs
Yes,
is
that's
from the
right.
centre of the Milky Way galaxy. And people are saying, well, how close does that put it to us? Well, we're about 8,000.
We're, yes, something like 25,000 light years
Yeah.
away. So, yes, you're right, 2.5 times further away.
Mm.
An interesting set of observations, a nice piece of research, because and I guess a lot of it is serendipitous. They're fortunate that Gaia happened to be looking at the same bit of sky at the same time. I'm not sure whether this was intentional, whether this work was, can you give us time on the Gaia spacecraft to look at a particular patch of sky, because we're going to look at it at the same time with a ground-based telescope, or whether it was a serendipitous observation. I need to follow up on that too.
Yes. But it's very interesting discovery, the fact that it came from two sources.
Yeah.
And
quite
so, and there'll be more of these to be found. And with all the new telescopes that are getting ready to be commissioned, we'll say, there's probably so much more ready to be discovered. It's just lurking out there waiting for the right equipment to point at it.
Yep, that's quite right. Stuff that we didn't even know existed until not that long ago.
Yeah. I suppose that's a question for you, Fred. We might as well ask. In recent years, have we seen a real escalation in the number of new discoveries because of technology that's improved?
Absolutely. You've only to think of the Webb telescope itself. We've got almost one story every day coming out from that of real significance. So yes, obviously the technology absolutely progressively has revolutionized astronomy. It's been the same for centuries, really. And the one I'm thinking of that perhaps did more than any other in terms of the giant leap that it made was photography.
Yes.
When photography could be applied to astronomy towards the end of the 19th century, then you were suddenly in a regime where you could actually make qualitative measurements of things that people had only really been able to look at by eye, and you could also see things that were much, much fainter than the eye would reveal. So that was one of the biggest leaps. Then 100 years later, effectively, we did the same thing, but electronically with the charge coupled devices and things like that are maybe 20 times more sensitive than a photographic plate. So you suddenly got another leap.
Yeah.
And then bigger and bigger telescopes. Yeah, it's a theme that has been close to my heart because my career is now so long that I've seen a lot of these things firsthand. I was using photographic plates when I started. That was the state of the art, the technology. I remember when I was at school reading about some I was going to say eccentric, maybe that's the word, French astronomer who was trying to make electronic images of the sky. And I thought, that's fantastic. That is superb. I want to do that kind of thing.
Yeah.
But it was still very experimental. Now, just press a button and there it is.
Yeah. Although you're still using photographic plates, you really need to move on, Fred.
There are some people who do.
I know there are.
It's not me.
Yeah, actually, retro is in at the moment. People, my daughter-in-law got a record player.
Good on her.
Christmas. So.
Yeah. Well, my turntable's right there.
Yeah, I've got one too. Although it's in a box in a cupboard. I don't know where it is. It's somewhere around here. But I can plug it into a computer, so I can digitize anything.
Very good.
It.
Yeah.
Yeah, it's amazing. So if you would like to read up on the Rogue Planet story and how they discovered it, you can do that at spacedaily.com. Fred, that brings us to the end of our first program back for the year.
Well, that's gone quickly, hasn't it?
It sure has. Yeah, it's flashing through them.
Yeah, no, that's great. And welcome to 2026. Who knows what we're going to see in 2026? Lots of astronomy events. We might talk about that in the next episode, what's coming up for 2026.
That'd be good.
You can find plenty of websites where it'll tell you. But I think we're in for an exciting year with the Vera C. Rubin telescope coming online and various other pieces of kit which we're going to find results from. It's going to be very exciting.
Absolutely. All right. Thanks, Fred. We'll catch you next time.
I hope so.
Professor Fred Watson, astronomer at large, joining us on Space Nuts. And thanks to Hugh in the studio, who couldn't be with us today because, he indulged in way too much Christmas cake and nuts and, well, you know the stuff. Anyway, apparently he's seeing someone named Jenny Craig about it. And from me, Andrew Dunkley, thanks for your company. We'll see you again soon on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Complete Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.